Okay, this is for parametric equations. Okay, you're going to see something new on the calculator today on parametric equations. Okay, and I want to do it by a couple of examples. One is a baseball problem, one's a golf problem. Okay, and this goes all the way back to 1919. In 1919, Babe Ruth, famous baseball player, Babe Ruth hit a home run. Which was the longest hit in Major League Baseball at that time. In 1919, Babe Ruth hit a home run, which was the longest hit in Major League Baseball. The trajectory of the ball is described by the parametric equations. And the parametric equations they're going to give us are x sub 1t is 96.9t and y sub 1t is 96.9 t minus 16t squared. Okay. Now, most of the time, if you're say here and you're showing the path of a baseball would look like this, right? And most of the time, in function mode, you would be able to say, okay, after 2 seconds, how high is that ball? Okay? Okay? Or you could say at a certain distance out. I guess I should say it that way. Function mode, you'd be doing distance out. You know, if you said after 2 yards out, how high is the ball? You know, after 3 yards out, how high is the ball? But in parametric mode, not only can you say how far out is it, how high up is it, how long did it take to get there. So we're going to look at 3 variables instead of just 2. Okay? The difference is you're going to look at time. So on this, for this example, and now not always t will be time, but for this one, t is going to be time in seconds. X is going to be the distance in feet. And that would be the distance out or away from the hitter. And y would be the height in feet. Okay? And then you have to figure a window. And not only are you going to do the x window, the y window, you also have to do the t. Okay, for a baseball, and you might just guess, oh, we're going to go 0 to 10 seconds, 0 to, you know, if you watch a game, how long does it take a baseball to get home run? Okay, well, I picked 0 to 7. And I'm going to go every 1/10 of a second. Okay, for the x. Now, I would pick a negative just so you can see the axis. So I did -1 to 600, and I went every 25 feet. Okay, and for the y, I went -1 to 150 and 25 feet. Okay. Okay, so let's look at your first parametric equation. When we look at parametric, this is function mode that you're used to. Okay, so you got to go to the mode key, and if it's a key, I usually circle it. And you want to go to parametric mode. Okay. Okay. So come down, and you got to press enter for that to register on the mode. Go to parametric mode. Now go back to your y equals. And you'll notice your y equals is changed. And they always, parametric equations will always come in pairs. You have to write down 2 of them. Okay? So they're giving us the 2 equations for this example. For x sub 1t, it's 96.9t. Go down to y sub 1t, it's 96.9t. It's the xt theta n key. Same key as x. That's a good question. It's the x. Maybe you need to put that down. It's the xt theta n key. It's that same key. Okay, and it's 96.9t minus 16t squared. Okay, now we need to set the window. Okay, go to window. My t, I'm going from 0 to 7 seconds and 0.1. Oops, sorry. 0 to 7 and 0.1. If you really want to slow it down, go every 100th of a second. That means it's plotting a point every 100th. Yeah, that takes a long time. The x, let's go -1 to 600. And let's go every 25. I mean, you could go every 50, every 100. For the y, I'm going -1 to 150 feet high and 25. Okay, and now graph it. Okay, and you should see a graph similar to this. The tick marks are different. Okay. Now the difference is put your trace key on. Okay. Now instead of just seeing x and y, you're going to see x, y, and more than one variable in parametric mode. Okay.
Now, is there anything you can check to see if they're rows and valid at the same rate?
If what?
Like if it rows and valid at the same rate, I mean, is there any way to check that?
If it's going up, it's going to come back down in the same.
Oh, well. Oh.
Yeah. Because your parabola is going to be symmetrical. Yeah. Is that what you mean?
Yeah.
Yeah. Yep. It will be. Okay. Okay. So on this, we put the trace key on, and then we looked at the, at the values, so you can tell. Okay. And if I change this t step, if I change that, it's going to change the looks of the graph. Okay. Go into your window. Let's say instead, let's take out that decimal. So basically I'm saying plot a point for every second. So just jump from 0 to the first second. How far did it go? To the second. So it's going to be choppier. Okay, see how it plotted a point from here to here, from here to here, here to here. Every second it plotted a point. If I went and I said change it to every 2 seconds, it's going to change the looks of the graph. Okay. Remember when we did like polar graphs that changed the looks? When we did change the angle? Yeah. Theta angle. If I do this, if I change this to 0.01, slow. Okay. Calculator's doing a lot of calculations. It's calculating every 100th of a second. Okay. So it slows it down. So if you need to slow down your graph, you can change the t step. Okay, if you need to speed it up, you can do that too. Okay? Okay, let's do one with golf now. We did baseball. Okay? Let's say we look at a golf problem. For this one, my x sub 1t is 49t. Yes. Okay, so let's go 49t for x sub 1t, and for y sub 1t, let's do 20t minus 4.9t squared. On this one, you got to change the window because the golf ball is going to go different. So on my window for t, I'm going to go -1 to 5. I could just go 0 to 5. And that's okay if you change it to 0. I don't know why I did -1 there, but you're not going to go negative in time. Go ahead and change that to a 0. I don't know why we did that. And then 200, I'm in yards now. And y, I'm going -3 to 40 and 5. Okay, so let's graph that one. Let's change the equation. You got to change them both. So this would be 49t. And for y sub 1t, we've got 20t minus 4.9t squared. Okay, and then change the window. Let's go 0 to 5 seconds. Whoops, 0 to 5 seconds. And let's go 0.1 for the t step. For the x, let's go -1. And I'm doing that just so you can see the axis, 25. And for the y min, let's go -3 to 40 yards high. Whoops, 40 yards high and scale 5. Okay, now if you put the trace key on, you can trace how long did it take to get up to its highest point, how long did it take to hit the ground. Okay, so you get that extra variable in parametric equations. Okay. Okay. That's a couple of examples. Now, I want to take you through function mode and parametric mode, how you can go back and forth. Okay? I just gave you two in parametric mode, but if I give it to you in function mode, you should be able to convert it back and forth. We're going to do a basic one to start, and this is going to be in function mode, and then we're going to go to parametric mode. Okay, a basic one to start is y equals x squared. And you all already know that y equals x squared is going to graph a parabola that opens up. Okay? Okay, if I want to graph it in parametric mode, I need two equations. Okay? You always let the x equal t. Okay, so my x sub 1t is just going to be t. So you're just going to let x equal t. So if I substitute t in for that, my y is going to be t squared. Okay, so in parametric mode, clear those two equations out. In x sub 1t, put in t. In y sub 1t, put in t squared. Okay, now, for the parabola, okay, you've got to, if I just do a window, let's say I just do 0 to 5.1, and let's say I do, let's do a -10 to 10, scale 1, and let's do -10 to 10, scale 1. Okay? And then graph it. Now I'm only getting part of it. Okay, I'm only getting this part. So to get that other part, I need to change my window. I need to change my t min. Let's say I change that t min to -5 to 5, scale 0.1. My x is still zoom standard, -10 to 10, scale 1, -10 to 10. Okay, now I get the other side. Okay, so on this, when you're just doing a regular parabola, your t, you are going to have to consider making a negative there. Okay, and my x, I just did -10 to 10, scale 1. My y, I did -10 to 10, scale 1. Okay, for every graph, if you want to go from function mode to parametric mode, you let x equal t to start, and then you just sub in. Okay, so another example. say I gave you a parabola y equals 3x squared minus 5x plus 7. And I know that's a parabola that opens up. Okay? If I want to graph it in parametric mode, I let x equal t. So everywhere you see an x in your equation, you're going to substitute in a t. Okay, so you'd put in 3t squared minus 5t plus 7. And then you would graph that. And you got to make a window that has a positive and negative t value, okay, to get both sides of the parabola. Okay.
You mentioned you switch the x to a y and to x to t or whatever.
Sub t in for x. That's pretty much it. Yep. Okay.
So why is the x sub 1.1 t just t? That's all it is.
That's all it is. Yep. If you want to go from function mode to parametric mode. Okay. 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 Enough to get you started? Okay.